Have you ever stopped to think about how our world just works? We're surrounded by these incredibly complex systems that run everything from the power grid to the factory floor. Well, today we're going to pull back the curtain and meet the hidden brains that make it all happen. I mean, really think about it. You flip a switch, the lights come on. You turn a faucet, water comes out. It feels so simple, right? But behind the scenes, there's this vast, complex orchestra of machines all playing in perfect harmony. So the real question is, who's the conductor? Well, today, we're going to meet them. And we're going to start at the very foundation with the absolute workhorse of the industry. This is the PLC, and it's where the rubber really meets the road, or, where the software meets the machine. So what exactly is a programmable logic controller, or PLC? Well, imagine a small, super tough computer. Its only job in life is to run one specific thing, say a single conveyor belt or a robotic arm on an assembly line. This thing isn't surfing the web or checking email. It just works 24/7 in all the heat and dust and vibrations you'd find on a factory floor. It's all about reliability. Now, you have to understand, PLCs were a total game changer. Before them, factories were run by these massive cabinets packed with physical relays and timers. Everything was hardwired. If you wanted to change even a tiny part of the process, you literally had to get out the tools and physically rewire the whole thing. It was a nightmare. Then PLCs came along and replaced all that clunky hardware with software. All of a sudden, you could change an entire production line just by uploading a new program. This was a revolution. So how do they actually work? It's pretty straightforward, really. You've got the CPU, that's the brain. It runs the program that's stored in the memory. Then you have input modules, which are like the senses. They read data from things like buttons, sensors, you name it. And based on that program, the CPU tells the output modules, the hands, what to do, like turn on a motor or open a valve. It's just a constant loop. Sense, think, and act, over and over. Okay, so we've met the workhorse that runs a single machine. But what if you need to run an entire factory? For that, you need to level up. You need to meet the conductor of the whole orchestra, the DCS. So let's zoom out. We're not just looking at one robotic arm anymore. We're looking at the entire car factory. We're moving from a single punk to the whole oil refinery. The scale here is about to get way, way bigger. And this is where a distributed control system, or DCS, comes into play. See, a DCS isn't one single giant brain. It's actually a whole network of controllers that are spread or distributed all over a facility, and they all work together in perfect harmony. Each controller handles its own little area, but they're all coordinated from the top. This is absolutely essential for things like chemical plants or power stations, where every single part of the process depends on every other part. This chart just nails the key difference. A PLC has a narrow focus, one machine, one task. Its control is centralized right there on the shop floor. But a DCS, it's got a massive scope, the entire plant, and its control is spread out everywhere. So think of it like this. The PLC is the highly skilled specialist, and the DCS is the general manager making sure all the specialists are working together as a team. So why do these huge facilities go with a DCS? Well, it really boils down to three big things. One, they're scalable. You can easily add more controllers as your plant gets bigger. Two, they are incredibly reliable, which is a must when even a minute of downtime can cost a fortune. And three, and this is a big one, they have redundancy. That means there are backup controllers ready to take over instantly if a primary one fails. It's a built-in safety net to prevent a total disaster. All right, we've gone from the machine to the plant. But what if your plant isn't in one building? What if it's an entire country's power grid or a water pipeline that stretches for hundreds of miles? For that, you need the top dog, the ultimate overseer, the supervisor, also known as SCADA. So let's do one final zoom out. We're going way beyond the walls of a single building now. We're talking about systems that are spread out over huge geographical areas. This is the biggest picture of all. And this right here is SCADA's turf. The name pretty much says it all: supervisory control and data acquisition. A SCADA system isn't typically doing the millisecond by millisecond control like a PLC is. Instead, its job is to supervise. It collects data from all these remote locations and gives a human operator a high-level view of everything, plus the ability to send commands back out over those long distances. And the process is pretty logical. First, you have sensors and little local controllers out in the field. We call them RTUs, and they collect all the data, like the pressure in a pipeline. Then, a communication network, it could be radio, fiber optics, whatever, sends all that data back to a central control room. And finally, operators in that room see everything laid out on big screens, letting them monitor the health of the entire system and make those big, critical decisions. Okay, so we've got all these different brains, PLCs, DCS, and SCADA systems. But how in the world do they talk to each other and to all the equipment they're controlling? Well, they need a dedicated nervous system. And you really can't overstate this point. It's so critical. You could have the smartest controllers in the universe, but if they can't talk to the motors and sensors reliably, you don't have a system. You just have a bunch of expensive, isolated boxes. The communication network is the connective tissue. It's what turns all these individual parts into one coordinated, living system. And these systems don't just use your home Wi-Fi. No way. They use these specialized, super robust communication protocols. You can think of them as the special languages that machines use to talk to each other. These industrial-grade networks are built for one thing: extreme reliability. They make sure that a critical message never gets lost, so the whole system can work in lockstep. And of course, these days, the Industrial Internet of Things, or IoT, is just pouring gasoline on this fire. It's adding way more sensors, collecting way more data, and creating way smarter connections, making these systems more efficient and more predictive than we ever thought possible. So look, if you take away just one thing today, I want it to be this simple hierarchy. It's so important. The PLC controls the machine. The DCS controls the plant. And SCADA supervises the territory. It's that simple. From the specialist on the ground to the manager of the facility to the regional supervisor watching over everything. Machine, plant, territory. Got it? And all of this leads to one last, really fascinating thought. We have built these incredible automated brains that run our world, and they're getting smarter every single day. So as they get more and more connected, the fundamental question we have to ask is, where do we draw the line? How much do we let them decide for themselves? It's definitely something to think about. Thanks for joining me.